All right. Yes. Thank you, everyone, for joining our the Bitcraze developer meeting. We're going to talk about the crazyflie and ROS 2. I'm going to mostly focus on showing some very simple examples of how to combine ROS 2 with the crazyflie. I'm very happy with so many people turning up. I did not expect that, but I hope to be able to teach you something today. So, as you probably all know, that's if you've ever flown with a crazyflie before, we have quite a lot of software and Python libraries that enable flight with the crazyflie. So we have the CF client, it's Python based, that's built upon the crazyflie Python library, and through the Crazy Radio PA. Now we have the Crazy Radio 2. The computer is able to communicate with the crazyflie through the Crazy Radio, the crazyflie real-time protocol. So yeah, so is that it? Is that the only thing that we support? Well, not really. We have some examples as well, like for other interfaces. Like we have done things with ZeroMQ before, perhaps like some MATLAB bridges as well. But today I'm going to talk about ROS and show you kind of like the examples that we have from both what we've been helping with developing and also what external people have been working on. So yeah, what is ROS? I guess I'm kind of assuming that you guys already know, but this is kind of like the copy paste from their own documentation. So that's it. It's a set of software libraries and tools to build robotic platforms. So it's yeah, kind of like from drivers to state-of-the-art algorithms like mapping or SLAM. It has kind of like an assembly of all. But that's not kind of all what ROS is. It's usually it's the strength is also in the way that the format has been set up. Each of the within the robot, you can set up different nodes. For instance, like you can have different nodes that drive the drivers of the wheels, like they're able to drive the wheels, or you have a different node that's able to do the planning, or the one node that does the mapping. So it's kind of like very versatile in that sense. You can kind of add anything you like. And between those ROS nodes, there are topics that are communicating between them, and there are services as well. I'm going to kind of like show you guys some hands-on to kind of show you what them actually mean with hopefully non-crashing crazyflie. But that's kind of like very much the very high level setup of what ROS is. And that is not simply to be explained in just a few sentences, but yeah, let's just start with that. So how we kind of came in touch, like at Bitcraze with the crazyflie came in touch, was pretty much because of the Crazy Swarm project. Well, let me just mute it right there. So this was work that was done at the University of Southern California with Wolfgang Honig and James Price, and they made a Wolfgang started with a ROS 1 package before, and they both worked on the Crazy Swarm ROS package, which enabled them to kind of like do swarm handling in sport, and also kind of like fly eventually also with about, I think 49 crazyflies was their top yeah, let's say records. And I think not a lot of people have been able to achieve that. And ROS was a very good tool in order for them to kind of like achieve that work. So that's very cool. Well, ROS 2, or technically ROS space 2. So ROS 1 has kind of existed already since 2007. Fortunately, it will come end of life in 2025. Not a lot of people are happy about that, because like a lot of people are used to working with ROS 1. But it kind of means it's like if anybody here is a beginner and wants to start out with ROS, you shouldn't start anymore with ROS 1, but you should start with ROS 2. That is of course more easier said than done. For instance, if your lab has big history of working in ROS 1 and all the packages are still in there, that might complicate things. Luckily, there are bridges between the two versions. But that is kind of like the reality of how things are, is that at one point we all have to switch to the new version. So this developer meeting, yeah, developer meeting is more kind of also kind of an getting started or kind of like a basics type of tutorial, I would rather say. Is that I will give some hands-on on some very ROS2 basics, and I will try to kind of show these basics. That's the nice, like, Open Robotics already have very good documentation on, but I will try to apply them directly on the crazyflie to kind of really show the implication, let's say. Hashtag demo effect. Let's see, or like, let's hope nothing crashes. I will also kind of like give some pointers to documentation, other projects to look at. And like in terms of the preliminary knowledge that I would hope that you are able to provide or something like that, is perhaps some very basic knowledge of the concept of ROS2. I think you would still be able to follow this if you don't. But perhaps if you have already started some of the beginner tutorials already, it would definitely help. And I would say like definitely some experience of the crazyflie Python library, because I'm definitely not going to go into that. I might say why I choose some of, like, for instance, like the commander functions in some of the implementation on the hands-on, because I'm going to do some live coding, let's say. But I'm not going to go into the library itself. We also actually have quite some documentation. So I'm going to show this on Ubuntu 22.04 with Ross Humble. That's the one that's supported for this version. I also currently I'm on Ubuntu right now, but I do also do a lot of the development actually on WSL on Windows with a USB bridge for the Crazy Radio, but I didn't want to take any chance because there are some instabilities there sometimes. So this is recorded, as you can see, and I will release the slides, video, and code after this meeting. So if you cannot really follow it, if you're complete beginner, you cannot really follow it completely, then that's okay. You can just try it again after that. Yeah, so I'll be doing some hands-on, but before that, I will just kind of show you a very basic principle of what I'm going to show here. So I'm going to start with writing a crazyflie node that is going to be a publisher, which means is that the crazyflie node will actually send some information on the ROS topic, and that can be read out by other nodes or like the tools that ROS will provide. After that, I'm going to do a hands-on of actually making a subscriber, which means is that the crazyflie node will actually subscribe to some information and act upon it as well. I hope maybe some flying. Let's see. So that is just a very, very basic example. Yeah, I think that's probably good for me just to get started. So I'll just share my screen directly. So you'll be able to see what I'm doing. So I hope everybody's able to see the code. If I need to make it a bit bigger, please let me know. So I've already made a ROS package here. I was kind of like doubting if I also should show you how to make a ROS package, but I will point you to the documentation later for that. So I have an existing ROS package, crazyflie ROS2 examples is the repository that I will also share eventually online. And what I'm going to do is I'm going to make a new ROS node. So I'm going to just start it with making a new file. So like, yeah, just a very simple run through first on one of these ROS2 packages, which, if you can kind of see here, let's make it a little bit bigger. It's maybe a little bit too big. So this is kind of like how the workspace looks like, and then you're supposed to make a source folder, and that is actually where the ROS2 example lies in, let's say. So so that's this example right here, and then the package itself. Here is where all the ROS nodes or that you can make. I'm going to focus on Python here. So I've already pre-made a couple of these hands-on examples right here, but I'm just going to kind of build them from scratch by making a new node. Then you have the standard like Python setup.pys, where you can kind of establish the ROS2 package, indicate where the nodes are. And these have already been set up, and this will be also kind of pushed to that one repository that I will share later with you guys. Yeah, so let's make a new crazyflie node where I'm just going to start from scratch, and I'm just going to be very lazy here and take a peek of what I've already done. And it's already a bit too big, so I'm going to make it a bit smaller. All right. So of course, like the important ROS imports should be added here. Which is like, you know, these are the standard ROS2 imports, which is the CRPI and the node, because we are of course going to make a node. I'm first going to make just a very basic class that only has anything that is ROS2 specific. So then you have an init function that you start here. I'm going to start with making a very simple publisher, which is in geometry message called point. That's 32. And the node will start with a main. Probably should turn off GitHub Copilot right there. All right, so I made a crazyflie publisher class here. This is probably need to indent this one bit. So you can kind of start it right here with. Yeah, you know what? I think this is going to be a little bit too complicated for you guys, and I'm not that well prepared. So I think I'm going to kind of do it a little bit differently and just go through the code for the crazyflie publisher example right here. All right, so let's start with main. So here's kind of like where you initialize the ROS node and the class that is actually inheriting from the ROS node here. And then you can of course like, you know, add any function like. So in this case, I want it to contain the URI of the crazyflie itself. Then this function right here starts the node. It starts like, you know, it is called a spin, but it just means is that it will just start the nodes, and if nothing really happens, it will kind of like close by itself. But it's so this is kind of like, you know, what actually physically started was to node by itself. So when the ROS node initializes, that's also where you would like to open a link to the crazyflie itself. Right now, there's a lot more callbacks that you can add from the crazyflie Python library. Like, you know, now I'm just going to focus on connected because that's the only thing that I actually care about right now. You can also add callbacks of if it disconnects, if all the parameters are actually downloaded and everything right now. But now I only care, is the crazyflie connected to this, to the ROS2 node or not? There was somebody that asked what a node is. I'm talking about the ROS2 nodes, which is yeah, let's see. Let's go back to yeah. I don't know actually fully how to explain that, but the crazyflie node is just the ROS2 node that I'm setting up. That is kind of like part of the ROS2 framework right here. It's what the one that enables all the like services and topics to run in between, so it makes it very modular and things like that. But yeah, I would actually suggest you to read the ROS2 documentation for that if you want to grasp better a concept for that. Where were we? All right, so here you would actually start up the crazyflie. Like I said, I only care about a connected callback, so that's the only thing that I'm going to focus on. My colleagues might say, like, what are you doing? Why? That's not safe, but it's all going to be fine. I will survive this. It's just a crazyflie. And then once you have the connected callback, you can open the link with the link URI that you provided right here. So why do I do this? Why do I use the connected one? Well, if I'm going to start logging, scribing right away, if I'm not actually physically connected, that's going to be an issue, and then the node will crash because I actually haven't received any data from the crazyflie. So that is not. So that's why for the connected callback, that's where I actually start all the logging variables of the crazyflie itself. So I'm going to look at the position. I'm actually with a crazyflie right here with a flow deck, so it should be able to detect its position. Very very big periods, so it's pretty much once per second, so it's very slow, just to make sure that the terminal doesn't flood with too many messages. Yeah, you add config to like the logging API of the crazyflie. You add the callback for that logging, specific logging, and then you make the logging start. So this is all still crazyflie library related. So that is then the position log data callback that is that's coming from the crazyflie. And in initialization, I initialized also if I start a ROS publisher, which this is then ROS2 specific. It would start a publisher of the type 0.32. That's usually, I think, the message standard that they use for position on the topic name topic. So, and that is then used here. So you first initialize a message of 0.32, which is an import that you add right here from Geometry messages. It's a standard. Well, it's not a standard message, but it's one of the more very used standard messages that ROS uses. So you initialize it as a 0.32 type. Then you fill in the data from the crazyflie logging data. So the state estimates .x, y, and z. And then you publish. It's actually pretty, yeah. Maybe it sounds complicated, but it's pretty simple. But I think it would be good to also kind of show you exactly what's then happening. So in the sense for ROS, you need to first, one moment. You would need to build the ROS2 packages or like nodes right here. That is a callcon. That's kind of like a building Python. So let's see if that's. I will just make the terminal a bit bigger. So you build it with callcon. Symlink install means is that I don't have to constantly change the Python script in order for it to automatically use that code. But yeah. Also, it's always important before you start a ROS2 script is to source ROS. So this is the so the opt ROS humble setup is just like the standard ROS installation And then you also have to make sure it has your local package installation as well. So you do that with source install setup.bash. So let's see if it can find the crazyflie ROS2 example. Yes, it can find that. 2 tabs. All right, so I have the talker. So that is kind of like the one let's turn on the crazyflie, because or else there will be not really much of a demo. All right. So if I've also kind of made a logging that actually says that that's actually publishing something. So I have some kind of visualization of what is, and you can also kind of see what is publishing it right here. So on the other side, let's source ROS again. I can check what kind of topics are listed now. All right, I see the slash topic, so I can do ROS topic echo topic. All right. Yeah, so that is kind of like the the positioning estimate of the crazyflie with the flow deck right now. So, but these are just a bunch of numbers. Maybe it's more interesting to show this from plotting functionalities. RQT is at least kind of the client that ROS has provided. And that's also kind of like a part of every standard install. So you can check out the topics right here. So you can see all the values that we're sending, that the Docker is sending from the crazyflie. But you can also do some plotting as well. Let me just there you go. Let's see. I want to have the X and the Y. It's very slow, so I'm not expecting it to really show something. But you can kind of like see what's happening there. Although I think the auto scroll might be a bit. So yeah, you can have some kind of like standard like Python or I mean some kind of plotting visualization. Although, let me just go back to the node right here. I kind of want it to run a bit faster, so let's do it like every 10 times per second. And since I've installed it with the symlink install, it should just work right away. So it's doing it a lot faster now. All right. Yeah, this looks a lot better, huh? So this is actually the X and Y position of the crazyflie right now. So you can either use this to look at it, you can write another ROS2 node to read it out and do something interesting with it. For instance, I don't know, some kind of type of controller type of nodes. But this is kind of like we're now really sticking with the basics here, since we don't have enough time to go through them all. All right. So that is just a very simple like ROS topic publisher. So I've used the 0.32 for this, but there's multiple messages types that also would enable you to check out the position on RViz as well, like pose or transforms. But that is like, you can definitely use the ROS2 documentation for that. Let's perhaps look at the subscriber example. So now the crazyflie was sending information out into the ROS world as a ROS node, but now we actually want it to do something with topics back, and so that this is a small example written for that. So these are all kind of like the same as before. Like I've now called a crazyflie subscriber, and the class is called crazyflie subscriber, but it's not that different as the first example. The only biggest example I would say is instead of setting making a publisher, you create a subscription to a topic. So you say you want to listen to this particular topic. This topic has a twist message type, which is twist is not a position, but it's like a velocity in X, Y, and Z and orientation. And that you want it to have this callback that will act upon those message types. Let's see what I'm forgetting that much. All right, so that is the listener callback. So you will get a quick log that it heard a certain message, and then it will do something interesting. Namely, it will actually send a hover set point. So I'm going to, for now, well, you know what? I'm just going to see if it will just fly. Let's go crazy here, and if it crashes, it's all me. So it will actually send this is the crazyflie commander send hover set point, which you will give it an X and Y velocity command that has a fixed height, and also like the yaw has an you also give it an rate command, but this is just all from the cflib right here. So okay, let's do the same thing. I already have this node installed, so I don't really have to worry about that. I think it's called subscriber. Yes. So if you forgot how you called your like ROS nodes that you want to start, it's a double tap is the way how to do that here. So yeah, subscriber tab, and then we have the crazyflie currently communicating. I'm just going to put the crazyflie on the floor right now and start the node again. And then I think you guys are, oh, one moment. I'm not sure if you're able to see it very well. Well, I hope I'm also not disconnecting with my screen right here. Is anybody able to see the crazyflie? Yes, all right. Okay, no guts, no glory. I'm going to, it's listening to the ROS topic, and I will give it a twist command in the other terminal. And then let's see what happens. Nothing happens. That is slightly worrisome. Like I said before, like this is typically what happens if you just want to do a demo too quickly. It has received it though. So I'm not exactly sure what is then going on. So let me just start again. Maybe sometimes it just, maybe in terms of initialization, it doesn't, maybe it hasn't initialized the IMU properly. That can be it. So let's just start the node again and hope for the best. Now I'm going to send it publish one message on the crazyflie topic. So just going to, nothing is happening. All right, that is unfortunate. Yeah, that's kind of what happens if you want to use show demos too quickly. So it is receiving. So like it definitely said like I heard the geometry twist right here. It was publishing one. It was supposed to actually get it on the fixed height, but it's actually not doing anything himself. So yeah, that's kind of an issue. But I will just move on because we don't have that much time. And hoping that the other example will work, or else this is going to be a very boring dev meeting. And I will just show you a lot of videos, which I. So Gus is saying the message is only containing 0. Yes, because it's technically like, yeah, because it's containing a twist message, but the hover set points is actually supposed to make it fly on a fixed height. Yeah, so that's why I put in the crazyflie node here a fixed height. So it will just make it take off to that certain position. And then, yeah, then the twist message was supposed to then make sure that it goes forward with like a 0.1 meters per second or sideways, but now it's not even taking off. So I'm a bit of a pickle here right now. So yeah, but it's yeah, but it's good that you noticed that. I'm just going to see if that will work later. It's a bit weird that it doesn't know right now, but like I said before, I had limited time of preparing this, so it's kind of a little bit on me. So let me just kind of like that is maybe the basic thing for how do you call it? Yeah, ROS2 nodes and topics. Nodes and topics for like publisher and subscriptions. What maybe is even a little bit more interesting is services actually. Wait a moment, I've lost the meeting link. Because with an service and a client, then you can start a service on the crazyflie node, and you only have to give it one command. So like with the twist topics and also like the set point hover, you would need to send it pretty much commands all the time. That's the same thing in the crazyflie library, and that's the same thing here because it's using the same functionality. If you stop sending it commands for 1 second, it will actually drop from the sky. Yeah, that is just a safety feature that's in there if you just use the regular commander framework. So that's why service is very handy, and that's also kind of what we're using for the ROS2 nodes, or at least the ROS2 nodes of the Crazy Swarm 2, but I'll explain it later. So that is also kind of like, I think, well, what also is very much one of the strengths of using ROS2 as well. So let's just go through the code. So this is kind of like a crazyflie like service. Pretty much same thing here. I've only changed the names. And here, same thing here. You create open the link with the crazyflie. I've created 2 services that is based on the standard service called trigger, which is not really saying giving it any information whatsoever. It just says, just do something. You can make it a little bit more sophisticated in the sense of you don't have to have a trigger. You can also, for instance, just create a service with a float message. And then that float can contain, okay, I want it to go to 0.3 meter or 1 meter. That is, yeah, that is kind of like, what you can actually use these services messages for. But now the request of the service is just like pretty much an empty, but what it sends back to the client, which requests a service, is just if it has been successful or not. So yeah, if this fails, it will never come back. So that's something definitely that you would need to add a try and accept here. But this is just a very, very simple example. Yeah, so let's see if things are going well. Just because I'm a bit paranoid, I'll just build it again just to make it, just to be sure. And I will start the service. Also an RQ, like you have done a ROS2 service list, so I can kind of check if it's there. And you see here like the service land and the service take off. So you can call upon the service from the command line. I can show how that is done and hope for the best. It was successful, but clearly it's not successful. Oh, wait. I know what went wrong. I disconnected all the motors. That wasn't smart. Obviously, it doesn't work. But that's actually good news, because that means is that I wasn't crazy. It was actually working before. I was just trying to be smart and be safe. And unfortunately, we don't have a way to kind of like warn us, like, hey, the motors are not disconnected. Like maybe until the crazyflie brushless is able to do that. But yeah, this one is not able to do that. Ah, stupid me. All right. So let me just start that again. I was going crazy. Like, it was just working before. Why? All right. Okay, let's start the crazyflie service again. So with the takeoff and landing service, just double checking if indeed they have started. Yeah, they have. So if they don't start, then yay! Finally. And you can also look at the crazyflie nodes that indeed it's taking off. So yeah. And of course, don't want it to for always take off. I also want it to land. Yes. Yay. My God. Okay. I'm sorry about that. But it means is that I can actually show now the subscriber example again. So I'll do that right away. Let me just close this note. By the way, if you would add the disconnected callback from the crazyflie library, you could implement that once it disconnects with the crazyflie, or you stop or you turn off the crazyflie, that actually the ROS2 node will also automatically stop spinning. It shuts down. You can actually implement that, but I haven't here. But just to let you know, just a slight tip. Yeah, so let's go back to the subscriber, or I think I just called subscriber. So yeah, all right. And then you have that one topic that hopefully is now working. Okay, yeah, there you go. So I'm going to publish one message on the geometry, on the command velocity topic right now. There you go. Oh no, it crashes. Or it doesn't really crash, it just lands gracefully, because that's what's supposed to happen. That was what I was first mentioning before. If you descend hover set point, if you only send it once and you don't resend it in an X amount, like within a certain amount of time, I think it's about two seconds, it will actually drop again. So that means is that you would have to keep on sending it. So let me just put it back to the position. And in ROS, if you're publishing a topic like this and you have like the dash dash once, it will only send one message. But if you remove that flag, it will keep sending it. and I think it crashed. Because now it's, I think it landed before so hard that it actually, the failsafe triggered and it doesn't want to take off anymore, which is supposed to happen. And you can also put in here that you're like, that you communicate the, let's say the status of the crazyflie through ROS, but like I said, these examples are very, very easy. So let's start a subscribe ROS 2 again, and then send topics again. Let me just first, there you go. To see the crazyflie, yes. All right, so now it just keeps on sending the twist message, and now it actually keeps on flying. And now, yeah, that's the kind of a quick question, because now I can actually not change anything to the twist message. So let me just make it crash. And also kind of like a good opportunity for show you how you can actually change this in RQT as well. And hope that the battery lasts a little bit longer, because I don't have any full battery here as well. And then you can look in RQT and look at the message publisher. It will send it by one frequency. I think that's okay. Let's see, was that? I think that's also okay. Yeah, actually, I can just send it like this. So you can select it here. Now it's flying again. And I will just give it a very small, like, rotational command. Do I dare to do that? Maybe. Let's see. There you go. Now it's very slowly rotating, but only once. And what I would say once per second is just slightly too little. Okay, let me just stop sending it. And now it fell down. Okay, I think that's enough for now, because we only have limited time. And like I said, these are just very basic examples, but the fact that I always want to show this on an actual crazyflie always adds more complexity to it. So let me just share the current presentation again, and I can show you some videos of things that are perhaps a little bit more, let's say, impressive. At least, like, if you already know what ROS is about. Yeah, so like I said, like, I only showed you the absolute basics. So I haven't even started with transforms, how to set it up with a launch file, what ROS actions are, what ROS like a simulation is. But perhaps you can kind of got a slight grasp, but at least like what the ROS framework can do for you, at least, like, and enhance like the possibilities that maybe this only the CFlip can. So there are a lot of tutorials that you can check out from ROS 2 itself, and there's also quite a lot of yeah. So it goes all the way from beginners to advanced, and that is, I think, definitely a good place to start. The CFlip API, where, like, with all the commander functions, is probably the handiest to kind of look at our documentation as well. We have automated API and documentation on the CFlip, so then you kind of have also kind of the information like, okay, which do you use set Hanfor point, or for instance, for the services, I use the high level commander, which is more suitable for that. And there's also quite a lot of external projects as well. So let me just show you the website real quick for that. Of all kinds of ROS2 related swarming examples as well. Like we have Crazy Swarm right here. We have the ROS, a couple of ROS ones as well. You also have some autonomy packages called Crazy Choir, and I think Aerostack also has some, yeah, let's say some support for the crazyflie as well. What is also very interesting for you that I actually forgot to say, add to the, let's say the presentation itself is you can also check this out, like at least for aero robotics in general. It's called like the aero robotic landscape, which also has like a lot of these type of autonomy, aerial autonomy stacks. Not all of them support crazyflie. For Crazy Choir, Crazy Swarm, and Crazy Swarm 2 already says it, but Aerostack 2 supports crazyflies. I think Kuma Robotics as well. So yeah, let me just send this in the chat so you can kind of like take a look at it as well. Yeah, so that is kind of like the external projects that either or not are using the crazyflie. And we and then I also kind of mentioned Crazy Swarm 2, which is now maintained by both Bitcraze and Wolfgang from he's now at TU Berlin. And then you have definitely like a lot more functionality implemented. Like Crazy Swarm is kind of more meant as a swarming tool, let's say. But we've also kind of implemented it to enable more things as well. So like here's, for instance, like the example of the like if you use the transform publishers to show it on Arvis. Oh, whoops, I'm not. Let me start again because I realized I didn't have the presentation open on the presentation. One moment. Yes, let me start again. So for I already mentioned Crazy Swarm 2, which is the currently experimental port for ROS 2 for Crazy Swarm, and it's kind of maintained by both Bitcraze and Wolfgang, and he's now at TU Berlin. And this is the video that I showed before. It's kind of like a swarm management tool, so it's kind of really meant for like swarming and path planning and like inter drone, yeah, collision avoidance, things like that. So like here you see a very simple, like, you know, the fact that you're able to use transforms to visualize each of the positions of the crazyflie, in also at least. I've also kind of like showed some examples of how to, and that's kind of what I meant with like using the strength of ROS, is that you can connect it to all kinds of other packages, like the mapping packages like StitSlam Toolbox or nav2 to make a map and do some yeah, some kind of like some of the basic path planning that they actually made for these mobile driving robots by themselves. So it's the multi-ranger is not great for the Slam toolbox. I will say right there. It is mostly not really. It's mostly more just mapping and you're hoping that the flow deck is okay. So that's why it's a bit twisted. But these are kind of like it really opens up a lot of possibilities for like the small platforms like the crazyflie. Yeah, so that is yeah. So I guess like there are going to be opportunities to learn a little bit more. So because like I said before, that I really only showed very much the very simple basics of RIS 2 and then like almost fully flying crazyflie. So on the Robotics Developer Day, that's organized by the Construct, I'm going to extend on that, bit better prepared with simulation on the crazyflie, and but then kind of like extend it to like, you know, how to make the service to make it land take off, how to make sure that it responds to twist messages, yeah, how to connect it to like one of those mapping packages that I've explained before. So I'm going to definitely extend that. Like what you've seen here, it was just a very purely executed teaser. So, and there's also if anybody's going to go to Robotics and Science and Systems conference, there's going to be a workshop on aerial swarms. And actually, it's all going to be based on ROS2, all the sort of the tutorials that we're going to show there, and we're actually going to show it on real flying crazy flies as well. Yeah, including Crazy Swarm 2. So it's Crazy Swarm 2, Crazy Choir, and Aerostack 2. So yeah, if you happen to go there, so please join. Yeah, I think that's it. Are there any questions? I think I went way over time, but hope that's okay. All right. Yeah, okay. Luigi said maybe I lost something, but in today's tutorial, how do you connect the crazyflie to ROS2? Yeah, that is kind of what all of those tutorials showed, but I can show you the important parts. So let's start with the very first example that I showed, which is the subscriber, or no, sorry, the publisher. So here, like, this is the crazyflie publisher class where you create an instance of. This is technically the ROS2 node that you start. So this is the ROS2 node that you start and you make it spin right here. That is exactly the same place where you open up a link. Oh, thanks, Patijn. That is indeed. Okay. Let's start again. So this is the crazyflie topic publisher. So this is kind of like where you create an instance of the class where you enter like the URI of the crazyflie. So this is important information. And this is like, the class that's the instance that is the ROS2 node eventually is being spinned right here. So that's kind of like started up for ROS2. And then initialization, that's actually where you both connect and open the link with the crazyflie. This is where you connect with the crazyflie. And this technically is now the ROS2 node. So does that answer your question? Yes. I will share all of this code later after we upload the recording and everything. But I can maybe share with you already. Let me just. I think I've already pushed most of this already, but let me just give me a second to share with you the codes right away here in the meeting. Here you go. All right. Any more questions?
Kimberly, no questions, but I just want to congratulate that you dare to do a real demo on a live thing as well. So bravo.
Thanks. Yeah, I slightly regret it, but I'm glad that in the end I found out
And
the
you showed
issue.
that it works actually. Don't worry. We're all having these problems, so
Yes.
completely understandable.
Yeah, exactly. This should be part of the checklist. But I should have realized that when the motors were actually not spinning upon startup. That's on me. But I'm glad that at least you saw something fly.
Absolutely. Thank
Yes.
you very much again.
No worries. Anybody else that has comments or questions?
Yes. Hello, everybody.
Hi.
We're a student group from Munich, and we're working on Crazy Swarm 2. Our task is to realize swarm behavior with the crazyflie 2 drones. And right now we're having trouble because whenever we're starting a command or a flight maneuver with 3 drones, for example, with the nice hover example from Crazy Swarm, always 2 drones instantly flip, and it's not working, and we were having troubles with realizing it, and we're wondering if it might have to do something with the flight rate or with
Radio rate.
with the radio rate, if there should be a limit, if it's some trafficking of signals that's
Yeah.
interrupting it, or if you have any ideas for us, maybe.
I have a couple of ideas maybe, but it's too bad that Wolfgang himself is not joining this meeting, because this was really like, was more a dev meeting really about the basics and not that much of about Crazy Swarm 2.
Okay.
But what I have understood from Wolfgang, that the CPP link backend, because I'm showing the cflib Python library here, which we also have a backend of on Crazy Swarm 2. The CPP backend, if you're using an AMD chipset, so a Ryzen processor, there we have heard that is giving issues. I don't know if you guys are running it from an.
We are using the virtual machine by Bitcraze. Is it?
Oh, okay. Wow. Yeah, there's a whole set of other issues on that.
Okay.
To be honest, you're running it from Windows, like
Yeah.
you want to run it from Windows. Okay. I use WSL myself with the UPD or USB IPD chain. I don't know if you have WSL2 enabled on your computer.
I can't say that right now. I don't know. I'm not sure.
Yeah, I'm like, yeah, I'm not necessarily sure. I haven't tried Crazy Swarm 2 from the virtual machine from Bitcraze, but I'm really sure that they, at least at TU Berlin, they don't test it out on that, and I am pretty sure they won't advise to do it from there as well. I think there's just a little bit some problems with the USB connections in there. So let me just send you the link to discussions. Because I would really much advise you to, at least for Crazy Swarm 2, to post it on there.
Oh.
I don't know if you've already done that or not. But yeah, like if you have that, like, if you just say it specifically what the issue is, and then I can at least give you maybe some pointers of how to do this on WSL2 on Windows, because I do that all the time myself.
Thank you.
But let's see. Yeah.
Okay, thanks.
Yeah. Are there any other questions now? Gus is saying, if I understand good, the field of possibilities of the ROS doable things is dictated by the cflib. Yeah, it's like, if the cflib cannot do it, ROS cannot do it either. That is definitely true. The CPP link from that they made for Crazy Swarm, so it has 2 backends. It also kind of enables broadcasting, so you're able to send multiple messages to all the swarm instead of just constantly one-to-one, what the cflib is mostly doing. But yeah, like if you want to do something beyond the control for of the cflib, then there's not that much that you can do. I don't know if you've looked at micro-ROS before. Let me just also very quickly send you the micro-ROS crazyflie example. They actually have managed to have like embedded ROS2 on the crazyflie itself, so that you're able to, within the crazyflie, do things in there, like within the app layer, and get some direct information out. That perhaps opens up a little bit more possibilities. I'm not sure if they've managed to do like a peer-to-peer communication from one crazyflie with micro-ROS to another crazyflie with micro-ROS, but then you would need to kind of like really go on the crazyflie itself in order you want to have more capabilities. But hopefully in the future we are planning to improve the communication stack of the crazyflie, and once that is improved, then ROS by itself can do much more as well. But yeah. So yeah, any other questions? All right. Yeah, then I think that's it for now. Like we can stop the recording and send